Hi there, this is Nick Hallgrimson from the University of Saskatchewan, and today I'm going to talk to you about landing asymmetries in back tuck saltos and the effect of takeoff asymmetry. Now, for those of you who don't know, a salto is just the technical gymnastics term for a flip or a single rotation about the transverse axis. Now, some background information as to why we studied what we did. Injury rates in gymnastics are high. In 2003, Kirilanis found that most injuries in gymnastics occurred during landings on floor exercise, and that this was the same between males and females. Colton Kirkby found that during their 18-month collection period, no gymnasts remain uninjured, and that 96% of the elite gymnasts and 65% of sub-elite gymnasts reported more than 3 injuries during that time. Now, many mechanisms of injury have been studied extensively. One that hasn't been studied as well is landing asymmetry, which is uneven lower limb loading patterns caused by a gymnast landing more on one leg than the other. This has been studied in gymnasts using primarily drop landings or drop vertical jumps, and a very limited amount of research has been done using gymnastic-specific movements. One study that did is a rather famous one by Panzer in 1987, and she found that gymnasts experience ground reaction forces up to 14 times body weight when landing a double back salto, so this square right here. And it was really interesting that when the gymnast landed, the total impulse values during a wipeout scenario were actually less than the impulse values in only the left leg in a poor asymmetric trial. Now, she then concludes that asymmetry has the high potential to cause injury. So we know these exist in gymnastics specific movements, but we don't really know why. But one group proposed that landing asymmetries are caused by 3 things. So Zook and Marinsek in 2013 said that they may be caused by lack of flight amplitude, a lack of angular momentum, or a lack of control of longitudinal angular velocity. Now, all of these occur during the flight phase, but they are mainly determined by factors at the takeoff, right? Because the variables cannot be altered once they're in the air as per the conservation of angular momentum. So if there's any unwanted forces causing asymmetric changes in momentum, this may result in unwanted rotation and might continue and not be corrected until the landing. Which brings us to the purpose of this current study, which is to examine whether takeoff force asymmetry is related to landing force asymmetry during back tuck saltos in competitive gymnasts. And we hypothesize that a manipulation of takeoff force asymmetry to either the right or the left will result in a corresponding change in landing force asymmetry. Now, to answer this question, we recruited 12 experienced male competitive gymnasts from provincial to international level, and they were injury-free. Now, before we actually had them do the back tuck saltos, we manually tested their leg strength using a handheld dynamometer with their leg at 90 degrees. And for the actual back tuck salto trials, we had them perform it from a 30-centimeter height, as you can see in the box right here. And our protocol was we had 5 baseline trials with no takeoff instruction, and then we had them lean with a 60% asymmetry to the right and perform 3 trials, and then 60% to the left and perform 3 trials at the takeoff. But those experimental conditions for the right and left were randomized. And now more about the actual setup. We had 4 AMTI force platforms. We had 2 independent ones at the takeoff, which are fixed to this box, and we had 2 at the landing, which are secured with gymnastics mats on top, a 5-centimeter gymnastics mat. And we also had a custom visual program for the gymnast to see and identify where their takeoff asymmetry was, so that they could find that ideal range of 60%. And for analysis, the asymmetry was calculated using this symmetry index. And for the knee extensor strength, we did a paired t-test between the right and left limb. And then we ran repeated measures, ANOVAs, for the vertical impulse and vertical force at both takeoff and landing. So what we found was that the right limb was actually significantly stronger than the left when looking at our knee extensor strength. For our takeoff asymmetry results, just to orient you, a positive value is a right asymmetry, a negative value is a left asymmetry. And post-hoc comparisons revealed, post-hoc comparisons for our symmetry index revealed significant differences between all groups, as you can see in the expected trend, where the right condition would display a rightward asymmetry compared to baseline, and the leftward condition would display a leftward asymmetry compared to baseline. Looking at the landing, the only two significant differences that we found were between our experimental right and left conditions. But takeoff asymmetry still did affect landing asymmetry, such that our left and right conditions caused corresponding changes in the landing asymmetry values compared to baseline. But there is an obvious rightward shift even with the baseline results. So recapping our hypothesis that the manipulation of a takeoff force asymmetry would result in corresponding changes in a landing force asymmetry. And what we found was that our takeoff manipulation, our novel takeoff force manipulation, was successful. Takeoff asymmetries resulted in landing force asymmetries that did differ between conditions, although not all. And similarly, landing impulse asymmetries were found to be different between conditions, although not all significant. So it's possible that takeoff affected landing asymmetry in the expected direction, but due to the significant level of rightward asymmetry, this effect was minimized and altered. The gymnast had significantly higher strength in their right limb, which may have predisposed them to preferentially favor that limb during landing, even though they had a symmetrical takeoff. A big point here is that both takeoff and leg strength asymmetries may play a role in landing force asymmetries in back-tuck saltos. Comparing our results to previous literature for peak vertical ground reaction force mentioned before, Panzer found up to 14 times body weight at landing, where in our study we had an average of 12.95, so quite similar. But to note, we had one participant with a staggering 21.8 times body weight. That's a lot. I don't think I've ever seen that in previous research. In comparing our average SI to other research, Morrissey in 2013 found an average of 14 to 15%, and Lilly found an average of 18.1%. Whereas in our study, we showed just over 10. And so it is significantly less. And we speculating that for a few reasons. One of them may be that there may be an effective effort, where in Lilly, Bradshaw, and Rice's study, they saw that as jump height increased, drop height increased, landing asymmetry actually decreased, and they associated this to an effective effort, where gymnasts are gonna try and land better when there's a more difficult task. And this landing from a salto is different and more difficult and requires more effort than landing from a simple drop landing, so it could be that. And also the gymnasts in this study were older, with an average of 19.4 years. So they may have more gymnastics experience and be potentially better at landing skills. So conclusions, significant landing asymmetries did occur even after symmetrical takeoffs. And this may be related to a leg strength asymmetry that we did see. Imposing a takeoff asymmetry produced significant differences in landing asymmetries in the expected directions that we thought they would. A limitation from this study is that salto gymnastic skills, like the back-tuck salto in this study, are normally preceded by other skills, possibly limiting the generalizability. Usually skills are preceded by like a round off or a back handspring. It's not as common to do it from standing. And then future work for this research is going to include an increase in sample size, an addition of kinematic analysis, and the inclusion of female gymnasts as well. Here are my references if you guys want to take a look at them. There's good stuff there. And once again, I'm Nick Hallgrimson from the University of Saskatchewan. If you have any questions, you can leave a comment in this video, or you can email me at nick.hallgrimson@usas.ca. I'd be happy to answer your questions, and thank you so much for listening.